Hey y'all, let's cover lesson 2, adding and subtracting whole numbers. Okay, expression 3 plus 4 shows the sum of two whole numbers, 3 and 4. And this expression, the numbers 3 and 4 are called the addends. Okay. You need to understand that sum means adding. Math is a language. So in order to understand how to utilize the language, the symbols are represented by words. Okay. So we can use a visual approach to find the sum using the number line. You start from 0 and it's a positive 3. And then you're adding another 4. So the answer is 7. What if we wanted to add 4 plus 3? Would we get the same sum? Well, yeah, that's the commutative property. So if we start at 0 and we go 4, and then we add another 3, 1, 2, 3. There you go. You end up at 7. So the commutative property of addition, which means that if A and B are whole numbers, so if A, let's make them small, A and B are whole numbers. Remember, whole numbers are 0, 1, 2, 3, 4, 5 to infinity are whole numbers. Then A plus B is equal to B plus A. Another example for that is what we just did, which is 3 plus 4 is equal to 4 plus 3. Okay. So what about, let's do an example. Let's do an example 1. Example 1. What about 5 plus 10? So 5 plus 10, is that equal to 10 plus 5? 5 plus 10 is 15. 10 plus 5 is 15. So yes, they are equal. So the sum, so adding two whole numbers, you can go either way on both of them, okay? 10 plus 5 or 5 plus 10. So one of the things that we use in mathematical notation is grouping symbols, parentheses, brackets, things like that. The symbols affect the order in which an expression is evaluated. So we can use parentheses, which are these guys. We can use brackets, or we can use the curly braces. Okay. Whatever is inside the parenthesis is evaluated first. Okay. So example, 3 plus 4 is inside the parentheses and then plus 5. You're not going to see the difference now. The difference is going to happen down the road. So get acclimated with following the procedures now we're going to be doing order of operation, PEMDAS. And this is just the baby steps of getting you started. People are so confused by order of operations or PEMDAS. And if we start working on it now, once we add each step every lesson or whatever, you'll find that it's easier to understand. So parentheses first, 3 plus 4 is 7, plus 5 is 12. Okay, you could take it out of the parentheses after you've done the 4 plus 3. I'll do that down here. When we are showing our work and writing mathematical statements, the rule of thumb is that one equal sign per line. Okay, one equal sign per line. It's kind of a rule of thumb. Work down, not across. It keeps it orderly, organized, easier to read, easier to see, and easier not to miss things, which is where the things typically go wrong in math. Work down. All right, so 5 plus 7 plus 9 is equal to 12. So if we're doing it this way, 5 plus 7 plus 9, you'd go 7 plus 9 is 16. Took it out of the bracket. And then 5 plus 16 is 21. I do like my answers squared, circled, something. The next one is 2 plus 3 plus 4. And you can have equal signs here. There we go. Is equal to 2 plus 3 is 5, plus 4 is equal to 9. All right. When we have grouping symbols that are nested, we should start with the innermost brackets. So if you find let's see if we get to that. Oh yeah, we've got practice. So let's do that in the next step. So we want to make sure that when we have grouping symbols that are nested, we should start with the innermost brackets. Okay, let's go to the second piece of this. Example 2. Or no, just example. 2 is part of the problem. 2 plus bracket, 3 plus parenthesis, 4 plus 5, close parenthesis, close bracket. So we have to start with the innermost parenthesis. Please do this to get this practice going. So I know it's nice, we can actually just go straight across and add them, but you've got to get the practice in of doing the same steps. So 4 plus 5 is what we'll do first. So 2 plus 3 plus 4 plus 5 is 9. The next one is 2 plus 9 plus 3 is 12. And finally, 2 plus 12 is 14. Okay, let's go to 2 plus 3 plus 4. So 2 plus 3 is 5, plus 4 is equal to 9. The next one, 2 plus 3 plus 4, would be 2 plus 3 plus 4 is 7. 2 plus 7 is 9. All right, what did these last two expressions tell you? Well, we've got a parenthesis over here with 2 plus 3 and then plus 4. Down here, it's the same thing, but instead of the parenthesis being on the left side with the 2 and 3, it's on the right with the 3 and 4. This is just to let you know. Oh, where did my thing go? Go in here. Placement of the parentheses doesn't matter with addition. Okay. So this tells you that placement of parentheses. I don't like saying this. I don't like saying doesn't matter, because it does. It doesn't matter when you're doing addition and whole numbers with addition, but anything after that, it matters. So I really don't want to write that placement of parentheses doesn't matter without that caveat. Doesn't matter with addition and whole numbers. Got to say that. Muy importante. All right, the associative property of addition. So what are we doing here? How do I want to say this? If A, B, and C are numbers, just numbers. So if A, B, and C are numbers, then A plus B plus C is equal to A plus B plus C. Yeah, I just say numbers. We can just say numbers for that. If it's just numbers and not other operations like multiplication, division, all that fun. So we're just doing addition. So I need to stop freaking out. All right, so A plus B plus C is equal to A plus B plus C. So that's the same thing as saying that 2 plus 3 plus 4 is equal to 2 plus 3 plus 4. Here's an example. Illustrating the associative property, let's say that 7 plus 3 plus 1, is that equal to 7 plus 3 plus 1? I don't know what this mark is. 7 plus 3 is 10. plus 1 is 11. 3 plus 1 is 4, plus 7 is 11. Booyah, that worked. Fabulous. All right, so addition has a number with a special property. This number can be added to any other number, and it will not change that number's property, that number's value. Added to. So it can be added to. What number can be added to any other number and not change that other number? And that's 0. 0. All right, so the whole number, this is the additive property, the additive identity. So the whole number zero is the additive identity. If A is a whole number, is any number, if A is any number, then A plus 0 is equal to A. Here's your example. 5 plus 0 is equal to 5. That's it. To add larger numbers by hand without using a calculator, we should line them up vertically and add. Okay, so 1, 2, 8, 6, add up to 3, 4, and 9. When you add, and add place value. When you add from right to left. So 6 plus 9 is 15. The second digit, 5, goes down. The first digit, the tens place, goes up. 8 plus 4 is 12, plus 1 is 13. The 3 goes down below from the 13, and the 1 goes, it carries to the hundreds place. 3 plus 2 is 5, plus 1 is 6, and then this one is just 1. So the final answer is 1,635. Not using a calculator. The key idea is that subtraction is the, well, it's the opposite of addition, is the opposite of addition. So for example, 7 minus 4. You start off with 7, they subtract 4 from it, and you end up at 3. Subtraction means add the opposite. Add the opposite. Sorry for the banging, I am having work done on the house. Is subtraction commutative? That is, does 7 minus 5 equal 5 minus 7? Well, 7 minus 5 is 2. 5 minus 7 is negative 2. So no, it is not. Subtraction is not commutative. Is not commutative. Is subtraction associative? That is, does 9 minus 5 minus 2 equal 9 minus 5 minus 2? Let's find out. 9 minus 5 is 4. Minus 2 is 2. 9 minus 5 minus 2 is 3. 9 minus 3 is 6. I'm thinking parentheses matter in this case. Wow, so no. Subtraction is not associative. All right, to subtract larger numbers by hand, you need to align them vertically and subtract from right to left. And we may need to borrow. So by hand, 5,635 and 288. We're subtracting them. Please notice that I lined up my ones, my tens, and my hundreds based on them. So I start from right to left. I need to be able to take 8 from 5, and that's not going to happen. You can't have 5 of something and take 8 out of it. Blood from a turnip doesn't work. So we're gonna have to go to its next door neighbor over at the tens place and borrow 10, which would be 1, which this 3 will become a 2. And we're going to add 10 to our 5. So this gives us 15. 15 minus 8, I can do. It's 7. Now I go to the next one. I can't take 8 from 2. So again, I have to borrow now from the hundreds place. The 6 becomes a 5, and we add 10 to our 2. 10 plus 2 is 12. So I went ahead and just stuck a little 1 out in front, which is what I typically do with mine. 12 minus 8 is 4. We can do that now. 5 minus 2, we can take 2 from 5. We're left with 3. And then 5 minus 0 is just 5. So our answer is 5,347. Some examples of borrowing. If you struggle with borrowing, let me know. We need to get you there. All right. In the absence of grouping symbols, it is important to remember that what? Addition is not more important than subtraction and vice versa. Addition is not more important than subtraction. Okay. And vice versa. All right. And lost my earring. And vice versa. All right. So we should perform additions and subtractions as they appear, working left or right. So we should perform additions and subtractions as they appear, working from left to right. As they appear, working left to right. All right. Example 25 minus 10 plus 8. Well, left to right, 25 minus 10. And then we're going to add 8 because there's no parentheses. So because there's no parentheses, I'm just going to go straight at it left to right. 25 minus, I don't want to do the 10 and 8 first. I want to go 25 minus 10 because it's left to right. 25 minus 10 is 15 plus 8. 15 plus 8 is 22. Okay. 13, 23. I knew there was something wrong there. I could feel it. 23. All right, geometry. If you took geometry, I don't know if you did or not. If you took geometry in high school, this is not the same thing. There's no proofs, there's no theorems. This is just very basic geometry. All right, geometry, a polygon is it's a flat plane figure. So it's flat, there's no dimension to it, you couldn't hold it. You couldn't see it as a figure like standing up. It's not three-dimensional. It's just a flat plane. So how can I say this? It's a plane, flat figure made up of a closed sequence, made up of a closed sequence, means in order, of segments, of line segments. Okay. The segments are, they have edges and they have sides. And there's a point where the two sides meet. It's called a vertex. So let me give you an example here. I'm just going to make just a random polygon. Okay. So this is a flat figure made up of a closed sequence of line segments. These are each individual line segments. All right. And the segments, they have the edges and sides. How can I say this? So you've got some edges or sides here. Edges, sides, whatever you want to call it. All right. There's a point where the edges and sides meet, and that's called a vertex. Everywhere they meet is a vertex. Okay. So, that page. The next part of, as we talk about the polygons, is you can find a perimeter of a polygon just by adding up. It's the distance around the polygon from one point all the way around the polygon and back to that point. So it's the distance around the polygon okay. For shapes with straight sides, you're just going to add up all the sides. So for shapes, not shades, shapes with straight sides, you're going to add up all of the sides. To find the perimeter, okay? So a quadrilateral, which means a quadrilateral means it's four sides. The four-sided polygon, well, it tells you that a quadrilateral is a polygon with four sides. Find the perimeter of the quadrilateral shown below, where the sides are measured in yards. Okay, so we've got all four have sides that with measurement. So I'm just going to start from here, go all the way around to that point. I've got 3 yards plus 3 yards plus 5 yards plus 4 yards. Okay, left to right adding 3 plus 3 is 6 yards. I guess I could have just added them all up, right? Because it's all addition at this point. So I'm just going to add them all up. 6 plus 5 is 11. 11 plus 4 is 15. So that's 15 yards. Here's something I need you to do a little bit differently for me. Okay, I want you to get in the practice of answering questions in sentence form. The reason for that is for this class going forward, and especially in the next class that you have to take with me, I need you to be comfortable with writing out what the answers are, not just 15 or 15 yards, but I need a sentence to show me that you understand what you just answered. So it says, find the perimeter of the quadrilateral shown below. Well, all you have to do is say the perimeter is the perimeter is 15 yards. That's it. I don't need anything fancy. I'm not grading on punctuation or capitalization or sentence format. Doesn't even have to be an actual quote unquote sentence. It'd be nice if you could get comfortable with doing that. I mean, we are in college, come on. So give me a sentence for your answer going forward. All right, and that's for everything. You can't do it on my open math, but you can do it for my quizzes and my exams. All right, a quadrilateral is a rectangle with all 4 of its angles are right angles. All right, so if you look at each of these angles for our quadrilateral, they are all right angles, which means they're 90 degrees. They are perfectly, this line is perpendicular to this line and for all of them around. All right, and it says find the perimeter of a rectangle shown below where the sides of the rectangle are measured in meters. Okay, so I can just add them all up. I mean, it looks like this side is equal to this side, and it is with a rectangle. This side is equal to this side with a rectangle. So this is 5 meters, and this is 3 meters. Let's add them all up, and I'm going to do them vertical. So 3, 5, 3, and 5. 8 and 8 is 16. So the perimeter is 16. Here's the deal as well. Besides sentence form, the other important thing to make sure you add is the units. Because 16 what? Sit-ups, push-ups, miles, I don't know. It needs to be represented in meters. Okay. let's go to the next quadrilateral, which is a square in which all of the sides are exactly the same for a square. All right. So these are each the exact same length. They're all the angles are 90 degrees, which means that all the sides are perpendicular. Okay. And so find the perimeter of the square that has a side measuring 18 centimeters. Well, there's 4 of them. So we know they're each 18 centimeters. And I can just add up 18 4 times. 8 plus 8 is 16, 24, 32. 5, 6, 7, 5, 6, 7. Yep. I had to carry on that one because we ended up with 32. So the perimeter is 72 centimeters. Got sentence, I've got unit, we're golden. Last page for this lecture. It says automobiles that run on alternative fuels other than gasoline have increased in the United States over the years. Example, the table below shows the number of cars in thousands running on compressed natural gas versus the year. So starting in 92, there was 23 vehicles. And in 2000, there was 101 vehicles that were running on compressed natural gas. The only compressed natural gas I've seen are buses, like New York City type. Cincinnati, I think. Things like that is where I've seen compressed natural gas. If you've seen any, please let us know in the comments, or just let us know in class. Table below shows the number. Okay, so we're going to do what? Create a bar chart. Ooh, showing the number of cars running on compressed natural gas versus the year. So I told you in my last lecture that the X or horizontal axis needs to represent time. Okay. So in this case, we want to represent the time on the horizontal axis. Which means we've got 92, 93, 94, 95, 96, 97, 98, 99, so I'm going to do each one of those represented. 92, 93, 94, 95, 96, 97. Ooh, I'm running out of space. 98. Oh gosh, sorry y'all. 99, 2000. Actually, what I'm going to do is I'm going to bring over my other one that I've already done. Just because my other one looked bad. Okay, so when I labeled my dates for the years, I had a title down here as well called year, because that's it's labeled as up here. And then for my vertical axis, it needs to represent the number. So it's the title is here, as well as this is done a little bit differently. Instead of 23, 32, 41, the line here took that there's over 100 representations for this left bar. So we need to have over 100 representative for our highest point so that we can represent where this bar is hitting. Okay. So because of that, we went with 110 instead of 101 and keeping everything in tens. So 110 would be 100, and then 90, 80, 70, 60, 50, 40, 30, 20, 10, and 0. All right, you want to go all the way down to 0. So we don't go up to 110, but we do go up to 101. And then we do go up to 89, and there it is represented. The 78 is where you want your bar to be hitting across from. And then you just create just straight down vertical bars. You can fill these in if you want to. You don't have to. You can just leave them as they are. The main thing is you've got your numbers represented in the proper format, as well as title and what type of graph or chart I'm looking for. The next one, I'm just going to leave it like this instead of drawing it myself. We've got the data from the previous table, which is represented here. Create a table that shows the differences in consecutive years. So for this one, the difference between 23 and 32 is 9. Between 93 and 94, they subtracted those two, and it's 9. Between 94 and 95, the difference is 9. And you subtract each one of those. From 89 to 101, the difference is 12. 78 to 89 is 11. So we've got all of our years, and then we have our representative of differences. So down here, when you create your line, we're going to create a line chart, a line plot. What consecutive years did the United States see the great? We can't answer that until we get a graph first. So first we graph with our numbers of the years down here, and then our differences over here. Our highest difference is a 13, so we want to have something just above that represented. We also want to have difference labeled and years labeled. All right. Then you come along and plot from 92 to 93, you plot up at 9. Same thing for 93, 94, and same thing for 94, 95. 95, 96, you've got to go up to 10. So you're just plotting the points. Don't draw the line yet. Just plotting the dots. 96, 97, you're going to go up to 13. 97, 98 down to 5. 98, 99 up to 11. And then 99 to 2000 is up to 12. Once you get those plotted, then you connect them with your line segments. Then the question was, in what consecutive years did the United States see the greatest increase in cars powered by compressed natural gas? Well, that was easily this one, 96, 97 to when they had, because they had 13 for the largest difference. Okay. So you would write that the biggest increase was in 96, 97. Just answer the question. No fluff, nothing extra. All right. And that's it for lesson 2. Good stuff. If you have any questions, shoot me an email, ask me in class, ask me in tutor sessions, anytime you can grab me. Let me know what your questions are.